You have probably felt it before. You are chewing a piece of peppermint gum, everything is normal, and then you take a sip of room temperature water. Suddenly, your mouth feels like it has been hit by a literal blizzard. It is like you just swallowed a liquid iceberg. But here's the crazy part. That water was not cold. That gum was not cold. If you put a thermometer in your mouth, your temperature has not changed at all. So why does your brain think you are currently experiencing the Arctic tundra? Why does mint feel cold when it is actually room temperature? Welcome to one of the most successful biological hacks in the history of nature. This is not just a flavor, it is a chemical illusion that is currently fooling your nervous system. To understand this, we have to look deep inside your skin and onto the surface of your nerves.
Your body is covered in sensors. You have sensors for pressure, sensors for pain, and very specific sensors for temperature. These are called thermoreceptors. Now, your body does not just have one generic temperature sensor. It has a whole team of them. Some of them are specialized to detect when things are getting dangerously hot, and others are specialized for the cold. The star of our show today is a specific protein called TRPM8. This is the primary cold receptor in your body. Usually, TRPM8 stays quiet. It just sits there on the surface of your nerve cells, waiting for the temperature to drop. Under normal conditions, when the environment around your mouth or skin drops below 78 degrees, TRPM8 starts to change shape. It opens up a tiny little gate on the nerve cell, allowing calcium and sodium ions to rush inside. This creates an electrical signal that travels straight to your brain. Your brain receives that signal and says, okay, things are getting chilly. But here is where the mint plant gets sneaky. Mint plants produce a specific organic compound called menthol. Menthol is a master of disguise. It is a small, waxy, crystalline substance, and it just so happens to be the perfect shape to fit into that TRPM8 receptor. When you chew on a mint leaf or a piece of gum, the menthol molecules flood your mouth. They find those TRPM8 cold receptors and they lock into them. But the menthol does not wait for it to get cold. Instead, it physically forces that little gate open, even if the temperature is 90 degrees. Because that gate is now open, your nerve starts firing that electrical signal to your brain. Your brain gets the message loud and clear, cold, cold, cold. It does not matter that there is no actual ice present. As far as your brain is concerned, those nerves are screaming that it is freezing, so you feel the sensation of cold.
This is what scientists call a thermal illusion. It is exactly the same mechanism as eating a spicy habanero pepper. In peppers, there is a chemical called capsaicin. Capsaicin does the exact same trick, but it targets a different receptor called TRPV1. That receptor is designed to detect heat and pain. When you eat a spicy pepper, the capsaicin tricks the TRPV1 receptor into firing, and your brain thinks your mouth is literally on fire. Mint is essentially the polar opposite of a chili pepper. One tricks you into thinking it is hot, the other tricks you into thinking it is cold, but both of them are lying to you.
But why would a plant do this? Why did mint evolve to have this weird chemical superpower? In nature, nothing happens by accident. Plants are stuck in the ground. They cannot run away from things that want to eat them, so they have to engage in chemical warfare. For a plant, menthol is not a refreshing flavor, it is a weapon. It is meant to be a deterrent for insects and small animals. If a bug tries to eat a mint plant, the menthol can be overwhelming or even toxic to their tiny systems. Over millions of years, the mint plant perfected this recipe to keep itself from being lunch. We humans are just the weird species that decided we actually like the feeling of our mouths being chemically frozen.
Now, let us go back to that water experiment. Why does drinking water after a mint feel so much more intense? If the menthol is already making you feel cold, why does the water turn it up to 11? It comes down to physics and sensitivity. When you have menthol in your mouth, your TRPM8 receptors are already primed. They are hypersensitive. The menthol has lowered the threshold for what the receptor considers cold. Normally, a sip of room temperature water might be 70 degrees. That is not cold enough to trigger a strong reaction from your cold receptors. But once the menthol is in there, those receptors are already half open. When that 70-degree water hits them, it provides just enough of a thermal nudge to make them fire with maximum intensity. Plus, the physical act of the water moving over the nerves helps the menthol penetrate deeper and hit more receptors at once. It's like you are supercharging a signal that is already being sent.
think about the economics of this for a second. Menthol is everywhere. It is a multi-million-dollar industry. You find it in toothpaste, mouthwash, gum, cigarettes, and even muscle rubs like Icy Hot. In fact, if you have ever used a cooling gel for a sore muscle, you are using the exact same biological hack. When you rub that gel on your skin, the menthol penetrates the outer layers and hits the cold receptors in your skin. Your brain feels the cooling sensation, which helps distract it from the pain signals coming from your muscles. It is essentially a chemical distraction technique.
But it gets even crazier. Menthol does more than just make things feel cold. It actually has mild anesthetic properties. This is why menthol cough drops are so popular. It is not just the flavor. The menthol actually desensitizes the nerves in your throat, making that scratchy, painful feeling go away for a while. It's a natural numbing agent. It's honestly incredible that one single molecule from a green leaf can manipulate our nervous system in so many different ways.
Have you ever wondered if there are other things that do this? Well, there are. There is a compound called eucalyptol found in eucalyptus trees that does something very similar, though it is not quite as potent as menthol. On the other end of the spectrum, scientists have created synthetic versions in labs that are way more powerful. There is a chemical called isolin that was developed in the 1970s. Isolin is estimated to be 200 times more powerful than menthol. Imagine chewing a piece of gum that felt 200 times colder than the strongest peppermint you have ever had. That would probably be a pretty terrifying experience. Your brain would likely go into a full panic mode, thinking your mouth was undergoing immediate frostbite.
Speaking of frostbite, can menthol actually be dangerous? In the amounts we find in food and gum, no, it is perfectly safe. But pure menthol is a different story. If you were to encounter 100% pure menthol crystals, it can be a skin irritant. In very high doses, it can even be toxic. But you would have to go way out of your way to ingest enough menthol to cause real harm. For the average person, the biggest risk is just that weird, watery brain freeze feeling you get when you drink a soda after a peppermint.
Interestingly, our love for mint is relatively recent in the grand scale of human history. While ancient Greeks and Romans used mint for medicine and perfumes, the mass production of menthol as a flavor didn't really explode until the 19th and 20th centuries. Today, the world produces over 30,000 tons of menthol every year. Much of it is natural, extracted from the Mentha arvensis plant, but a huge portion is also synthesized in massive chemical plants. It is one of the most recognizable sensations on the planet. So, next time you pop a mint, take a second to appreciate what is actually happening. You are not just eating a candy, you are engaging in a 5 million-year-old game of chemical warfare. You are intentionally confusing your nervous system. You are tricking your brain into thinking it is standing in a freezer while you are actually just sitting on your couch. It is a reminder of how easily our senses can be fooled. We think we see and feel the world exactly as it is, but really, we are just interpreting a series of electrical signals. And sometimes, all it takes is one tiny molecule from a leaf to make us lose our cool. Literally. Is it not wild that our bodies are so easily hacked? We have these incredibly complex nervous systems, these advanced brains, and yet a simple plant can come along and just flip a switch that says cold. It makes you wonder what else we are missing. What other chemicals are out there that could trigger receptors we don't even know we have? For now, we will just have to settle for the refreshing, icy blast of a peppermint. Just maybe wait a few minutes before you drink that water, unless you are really looking for the full 4D Arctic experience. Thanks for watching, and stay cool.